Good morning, everybody. My name is Fabio Benedetti. My advisor is the Professor Sonia Bergamaschi. And the title of my presentation is Revealing the Underlying Structure of Linked Open Data for Enabling Visual Querying. So here is a summary of the activity of my PhD. In the beginning, I studied medical ontology and e-health, and I find out that a lot of these kind of resources are contained in linked open data. So I switched my topic in linked open data, and in particular, I define some technique of schema extraction and ontology summarization. More in detail, I define technique of index extraction. I define a new model called Schema Summary. I develop a tool for visualizing this schema summary and for enabling visual query building over this schema summary. In the last part of my PhD, I developed another technique during my period abroad, which is called context semantic analysis. In this presentation, I will focus in the middle part, where there is the which is the greatest part of my work, but now I put just some slides about these other two topics. Regarding the medical ontology, I collaborated in a regional project called CNIS with the Sears feed, so the University of Bologna and the University of Ferrari. I did a keynote in a second level master organized by the Sears feed, and I also published an article in a volume called Strumenti, diritti, regole, nuove relazioni di cura del paziente europeo nell'e-health. For the second topic, I developed this technique called context semantic analysis when I was in the Econoesis Research Center in Dayton, Ohio, under the supervision of the professor Amit Sheth. Very briefly, this technique exploited the information contained in a knowledge base for estimating the similarity between documents. This work is not yet published, but it will be present in my thesis. So now the main topic, schema extraction and ontology summarization from load sources. This is a picture, a snapshot of the linked open data cloud. Each circle in this picture is a data set. So the number of data set in the last few years is increasing very quickly, but a main problem in this context is that discovering and consuming this kind of data remain a difficult and complex task. But here the main problem is that does not exist any standard way of documenting the data set. There are some standards like RDFS or OWL, but they are not used. Used for describing the schema of the data set, but they are used for defining some ontology constraints. Another problem is that the number of vocabularies for describing data on the web is increasing very quickly, and the most important point is that a generic data set is usually not self-explanatory. So because a lot of resources are defined outside the data set. Here are the result of a study that I conducted. I expected 185 data sets looking how many properties and classes are defined outside the data set. As you can see, for more than 60 data sets, the number of resources defined outside is the 100%. So for trying to find a solution, I defined a new model called Schema Summary that aims to provide a simple representation of this schema of a generic data set. The schema summary is automatically extracted, can be applied to any generic RDF source, is self-contained, and is easy to visualize the schema summary and have an intuition of the structure of the data set. So here is the formal definition of the schema summary, which is a data structure, and in particular a pseudograph, in which the nodes are the classes and the edges are the properties. It contains also additional elements. We can associate to each class a set of attributes. We have a set of labels that are the URI of the resources, classes and properties and attributes. We have a labeling function, and we have also a count function that can embed in the schema summary some statistical information. The schema summary is extracted looking at the distribution of the instances of the data set. I defined also a clustered version of the schema summary, but for brevity I will not speak about that in this presentation. So here is an example of the content of a generic data set. As you can see, the data can be divided in two portions. We have on the top the intentional knowledge, but as I said before, this is the knowledge that describe the classes and the properties, but in a lot of data set, this portion is not complete and sometimes also missing. So I focus my work on the bottom part, which is the extensional knowledge, where we have the real data, the assertion, usually the instances. In this example, we have four instances, one sector, two organizations, and one person, and all the triples that describe these instances. I define some instances for extracting information from the extensional knowledge. The most important are three. The first one is the subject class index that is composed by pairs PC, where P is an object property and C is a domain class. In the example is colored, this pattern is colored in green. We have organization X sector 2 times and organization X CEO. The second index is a subject class to literal, where is similar to subject class, but in this case the property is a data typed property. So this kind of property have a literal as object, and in the example they are colored in orange. And the last one is the object class. In this case, P is an object property, and this time C is a range class. And in the sample, they are colored in blue. So having these indexes, now we can generate through I can generate through an algorithm the schema summary. This is the schema summary of the previous example. As you can see, is quite simple. We have three classes connected through two properties, and for each of these classes we have a set of attributes. I implemented an application over this concept of the schema summary, and this application is called Lodex, and his main goal is to promote the understanding, navigation, and consumption of linked open data, also for unskilled user. The application is divided in two main modules. The first one is the extraction and summarization module that take in input just the URL of a SPARQL endpoint and produces as output the schema summary. And the second one is visualization and query. This module take in input the schema summary and provide to the user this browsable version of this schema summary, allow the user of building query over the schema summary, and so on. So more in detail, the first process is the index extraction process, where this process is able to automatically generate the Sparkle queries that are used for extracting the indexes. It contains also another technique called pattern strategy, which is a technique that is used for handling the problem of Sparkle endpoint with low performances. The second process is the post-processing process that taking input that takes these indexes and through an algorithm produces the schema summary. The second module is composed by two sub-processes. The first one is the schema summary visualization process, which is implemented through a web application. It's composed by three main panels. The first one contains all the list of the datasets indexed by LODEX. The second panel is the schema summary panel, where the user can browse the schema summary and build the query. And the third one is the refinement panel, where the user can refine the query. The most important component here is the query orchestrator. It manages the interaction between the user and the user interface, and it contains another data structure, which I define is the basic query that allow the query orchestrator to store the query while the user is building it. And it contains also a Sparkwell compiler that taking input the basic query and the schema summary for producing through an iterative algorithm the corresponding Sparkle query. So here is the main panel of LODEX. This one is the schema summary of this dataset, linked clean energy data. Now the focus of the user is on the class organization, and here we have all the details of this class, the properties and the attributes with some statistical information. The user can build here a visual query and can add some attributes and properties to the query just clicking on this button. When the user wants to generate the Sparkle query is directed to the refinement panel. This is the corresponding Sparkle query generated by LODEX, and the user can also visualize the result, can, with the panel of the top, can refine the query, adding some filtering condition, pagination, ordering, changing attributes and classes, and so on. So how I evaluated this model? I evaluated this model using Ontology Summarization metrics. First of all, I expected the coverage, the compression, and I performed another kind of evaluation called application-driven Ontology Evaluation. In this table we have the test set, the number of the test set involved in this evaluation. So first of all, I define the coverage as the percentage of triples in the RDF source that can be represented through the schema summary. As you can see, obtaining a quite high coverage. The average is more than 80%, but for a small group of data set, I obtain a low coverage, and that is due to the kind of content of this data set. They contains a high quantity of intentional knowledge, so they are more ontology than open data, but it is just a small portion of the total, so the results are quite good. After that, I evaluated the compression, so I designed an algorithm for translating the schema summary in an RDF-S ontology. And then I defined the space-saving matrix as the percentage of reduction in number of triples between the intentional knowledge of the source dataset and the RDF-S ontology that I generate. And here I obtain a space-saving factor of the 99% for the greatest part of datasets. For the application-driven ontology evaluation, I evaluated LODEX because LODEX is the implementation of the concept of the schema summary. And here I evaluated two things. First of all, if the representation of the schema summary is clear and can represent the structure of the data set, and the second thing is if the visual query building functionality is adequate and easy to use for both skilled and unskilled user. I perform also other kind of evaluation about LODEX, but I'm not going to present it here. For evaluating the usability of LODEX, I designed an online survey, and I enrolled 27 anonymous users. Here you can see the distribution of the ages of these users. And here there is the level of knowledge of this user about semantic web technologies. We have half of the users that are not skilled and the other half that are quite skilled. And I defined some micro tasks that the user have to complete in the survey, and as I said, I divided the survey in two parts. In the first part, the tasks are like finding classes, properties, and attributes or values inside the schema summary, while the second part, I asked to the user of building a visual query starting from some natural language request. In the end of this survey, I put a SUS questionnaire for evaluating the usability of LODEX. Here are the results. I obtained a SUS score of 85.5 that rank the usability of LODEX as excellent. There are no remarkable difference between skilled and unskilled user, and that is a good result. And also the percentage of current answer to the task that I propose to the user is quite high. We have 91% for the first part and 90% for the second part. So here are the list of my publication and project, and that's it. I remain at your disposal for any question.
Thanks for your talk. Like in the previous case, we have time for one question if you...
Just a curiosity. Could you tell us about a possible application and for commercial use, for example?
During the conferences where I presented the paper, a lot of I spoke with some companies, and they are quite interested in this tool because sometimes they are putting data inside some RDF data store, but they don't know how the data is structured inside because it is always changed. They are maybe start using other properties, they stop using other properties, they add some classes and so on. So this tool can the tool can easily index the source and provide a panel for visualizing the structure and for helping the user in building a query, because a user that have no knowledge of SparkWell can also a user that have no knowledge of SparkWell can, with this tool, building query and extract information. That is on GitHub. I have to finish to clean some stuff, but yeah, it will be. Thanks.